Okay then, so we're going to look at 2018 higher level 10C in terms of its working out. So the first thing that we always do is we write our ratio for our equation. So it's 1 is to 2 is to 2 is to 3. We then read our question. So rusty object was coated with phosphoric acid. All of the rust taken as Fe2O3 was converted to iron phosphate according to the balanced equation. The iron phosphate formed was 4.53 grams. So that's what we're going to go in here. And now our question is asking us how many moles of iron were removed from the object. So if you look at the equation, there is no standalone iron atoms. So this one is going to have a little funky way in. So we're trying to figure out moles of iron. And the only way in is going to be using this 4.53 grams. So if it's grams, it's a mass triangle. So we need to calculate our molar mass for our iron phosphate. So this is going to be 56, it is going to be 31, and it is going to be 16 by 4. And when we've put our iron phosphate together, we should have 151. So we're back over here to our 4.53, and we're dividing it by 151. And when it does that for us, we are getting 0.03 moles. So here's what we have. We have iron phosphate, and it's got 0.03 moles, and we want to find out moles of iron. So what we need to do is we need to break this apart. And when we break it apart, we get 1 Fe, 3 plus technically, and we get 1 phosphate, 3 minus. So we work it as a ratio. The ratio is 1 is to 1 is to 1. So if I have 0.03 moles of iron phosphate, I have to have 0.03 moles of iron, and I have to have 0.03 moles of phosphate ions. So for the answer to part 1, how many moles of iron was produced? This is our answer. Now, again, some candidates can't recognize that they have to break apart a compound. Sometimes you have the iron and you have to go back and work out your ratio for what is within a compound. But if you couldn't do that particular part, you're only losing the part I, because technically from this 0.03 moles here that we got as our answer for the moles of iron phosphate, we can rewrite our moles ratio. So this would be 0.015, 0.03, 0.03, and 0.045. So this is our moles rewritten to take the ratio into account. And we now look at the rest of it. What mass of rust was adhering to the object before treatment? So we're over here now. It is a mass, which must mean we need a mass triangle. So we need to calculate the molar mass of Fe2O3. So that is going to be 56 by 2 plus 16 by 3. And that gives me a mass of iron oxide of 160. So 0.015 by a molar mass of 160 gives me 2.4 grams of iron oxide. So this is going to be my answer. In terms of significant figures, there's only 2 significant figures in that answer. It's going to be fine. For number 3, what is the minimum volume in centimeters cubed of the phosphoric acid? So it is this number of moles we need. Now, it's asking for volume in centimeters cubed. There is no mention of STP or RTP, so no mention of these, so I can't use volume triangles for these. We are not doing ideal gases. It's phosphoric acid is a liquid, so there's none of the PVs equal to nRT, or there's no combined that we can use for this. So what is left? This is essentially a fourth triangle. This is the one that we want that's used rarely. So the fourth triangle has moles on top. It has the concentration that is in big M, and it is multiplied by V over 1,000. So our question, part 3, says minimum volume in centimeters cubed of a 6.0 molar solution. So we have everything we need for our triangle. So we're trying to find out the volume. So the way I'm going to write this is, I'm going to write it as 0.03 for my moles divided by my 6. And we're going to make this equal to V over 1,000 because just for ease of use. Now I need to get this 1,000 over to the other side of my equals. So it's going to go 0.03 multiplied by 1,000 divided by 6, and that is going to give me the volume that I need. And when I work it out, my volume now should be 5 centimeters cubed. So the giveaway in that part of the question was this 6 centimeters cubed and the volume. That can only bring me down here to this mass, or fourth triangle as we call it. Has to be that, can only be that. And the last thing was, what volume of liquid water with a density of 1 gram was produced in the reaction? So this is the part of my red box that I'm interested in for part IV. So we have 0.045 moles, of water. We have, the question is asking us what is the volume if density is 1 gram per centimeter cubed. So again, we have to keep talking to yourself. Here for volume, there is no mention of RTP or STP, so I can't use my volume triangle. This is the giveaway, the fact that there is density and we want to find out volume. So we're looking at our density triangle. So density is equal to mass over volume. I can use my moles here to find the mass. So we're looking at H2O. So it'll be 1 by 2 plus 16, which will be equal to 18. So moles by molar mass will give me a mass by 18. So when I do that, it's going to give me 0.81 grams. And now I'm going to plug into my density triangle. So we now have a mass of 0.81. We have a density of 1. When I do that out, it's going to give me a volume of 0.81 centimeters cubed. Final answer. Now, this again, straightforward question. You're bumping from triangle to triangle. Once you get this red box up here, life is great. The trickiest part, or the places we said where candidates last mark, was working out moles of iron. So again, if you can't figure it out, you just pick a number and go with that. So the most candidates would have lost 3 marks here. They just wouldn't have got them, but they would have, if they recognized that we could write our red box moles, taking the ratio into account, then they were getting the vast majority of the marks. So just to talk about, we had 2 different volumes in this question. There was no mentions of RTPs and STPs, so that puts it out, but there were other hints. So the other hint was this, said fourth triangle, and this says our density triangle. So you just have to keep calm. I think you need your triangles out in front of you when you're doing these pieces of maths to see, can you recognize what's needed, and away you go.